For astronomers, Omega Centauri has been an outcast amongst globular clusters for a long time. A new result obtained by the NASA ESA Hubble Space Telescope and the Gemini Observatory provides a surprising explanation for Omega Centauri's peculiarities.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Welcome to the Hubblecast. Today's cosmic guest star is a very special object. Omega Centauri has long been known to be the largest and brightest globular cluster visible in the night sky. Now, a globular cluster is a nearly spherical group of tens to hundreds of thousands of old stars, tightly bound together by gravity and found in the outskirts of many galaxies, including our own Milky Way. Beautiful but enigmatic, Omega Centauri has always been a bit of a puzzle to astronomers.
Omega Centauri lies in the constellation of Centaurus and is visible from Earth with the naked eye. It's one of the favourite celestial objects for Southern Hemisphere stargazers, appearing almost as large as the full moon when seen from a dark site. Exactly what type of object Omega Centauri is has long been a contentious topic. It was first listed in Ptolemy's catalogue as a single star nearly 2,000 years ago. In 1677, Edmund Halley reported it as a nebula. In the 1830s, the English astronomer John Herschel was the first to recognise it as a globular cluster, a classification that it has kept ever since.
Omega Centauri has several characteristics that separate it from other globular clusters. Compared to a run-of-the-mill globular, Omega Centauri has a highly flattened shape, it rotates faster, and it includes several generations of stars, which is an unusual feature for globulars which normally contain only a single generation of old stars. Moreover, Omega Centauri is almost 10 times more massive than other globular clusters, almost as massive as a small galaxy. Now, new images obtained with the Advanced Camera for Surveys on board the NASA ESA Hubble Space Telescope and data obtained with the GMOS spectrograph at the Gemini Observatory show that Omega Centauri appears to be harboring an elusive intermediate mass black hole at its center.
The black hole was discovered after astronomers measured the motions and brightnesses of stars at the centre of Omega Centauri. They found that these stars were moving much faster than expected given their total number and brightness. Such behaviour clearly indicates the existence of something extraordinarily massive at the centre of the cluster. The intense gravitational field of a black hole with a mass of 40,000 solar masses provides just the kick necessary to explain the measurements.
This is Dr. Eva Noyola of the Max Planck Institute for Extraterrestrial Physics in Germany. So Eva, you were the lead author on this study. How did you find this black hole?
The way we found this black hole was by looking at the Hubble image and measuring how many stars are there at the very center of this cluster. And then we take the GMOS spectrograph and measure velocities, the velocities of these stars. What we find is that the velocities are much higher than what we would expect just from the stars. And that implies that there's an extra amount of mass there, it means that we found a black hole.
And what's so special about this black hole?
The very special thing about this black hole is that it has 40,000 solar masses in size. So that means it's a lot bigger than the stellar mass black holes that we find in our galaxy, but it's much smaller than the supermassive black holes that we find at the center of galaxies. So it means that nature makes black holes in a continuous mass range, not just in small and big sizes.
So what's the big deal? Why is it so important?
Well, first of all, this is only the second black hole that we find in a globular cluster, so that is a very nice, reassuring thing. But also, we know that there are seeds required to grow the supermassive black holes from scratch. And if we find many of these, then that would be a very nice source for these seeds to grow the supermassive black holes.
One implication of this discovery is that it is very likely that Omega Centauri is not a globular cluster at all, but rather some kind of dwarf galaxy that has been stripped of its outer stars and dark matter, as some scientists have suspected, for a few years. More than 2,000 years after Omega Centauri was wrongly classified as a star, its true nature is finally coming to light. But I wonder, does Omega Centauri have more surprises in store for us? This is Dr. J, signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.